Hey everybody, welcome to, this is the last section in chapter 2. Essentially, this is sort of an add-on section. This is compound inequalities and absolute value inequalities. It's just a slightly different flavor of what we've been doing. So remember that an inequality is an algebraic expression related by one of these symbols, greater than or equal to, less than or equal to. When we graph inequalities, we use parentheses when it's not less than or equal to, and brackets when it is. A compound inequality is two inequalities that are linked by words. It's either the word and or the word or, and they mean different things. And what we're going to do is go through and see examples of that. And we have to think really carefully about. So we're going to solve. We're going to solve one side and the other. This one says x plus 3 is less than 1 and x minus 4 is greater than 2. So we're going to subtract 3. We get x is less than negative 2. And x, oh, sorry, I was just going to subtract 4, but I just tried to subtract everything. Plus 4. So we get x is greater than 6. And now you really need to stop and read it to yourself. So it says x is less than 2, negative 2, and x is greater than 6. Can x be both of those things? No, right? A number, you can't have a number that is less than negative 2 and also greater than 6. Can't be both of those things at the same time. It's like if I said to you, okay, I'm gonna have a party and I'm gonna have an elephant and a giraffe. If you came to the party and I only had an elephant, it's a bummer because I promised you an elephant and a giraffe. If you come to the party and only have a giraffe, it's a bummer because I don't have the elephant. For it to be true, for an and statement to be true, it's got to set both. It's got to both have to work. But in this case, neither works. So the answer is empty set. It's no solution. It can't be both at the same time. Let's try another one. So this one, let's solve number 3 over here. Divide by 3. So I have 3. I'm going to have x is less than or equal to 3. And let's see, I'm going to divide by negative 4. I have x is, remember when I divide by a negative, I'm going to swap the sign. And it's less than or equal to 3. Well, in this case, I have both, right? They say the same thing. So x is less than or equal to, hard bracket, 3. It's absolutely true. It can be less than or equal to 3 and less than or equal to 3. Totally works. Let's try the next one. Negative 3. I think this might be the same one we just did. Oh, slightly different. X is less than negative 12. And if I add 4, I get x is greater than negative 8. So let's think about what that means. X is less than negative 2 and greater than negative 8. So it's got to be numbers in between negative 8 and negative 2. Like negative 6 would work, but negative 10 would not. Okay? So here's the thought. If we have A is less than B and we have two inequalities, A is less than B and X is less than B, then we can write these as a compound inequality. We started this in a previous lesson. So we can rewrite something like this as a compound. Negative 4 is less than or equal to less than negative 4x is less than 24. That's the idea here. And then we can solve it. So we're going to do that on the next screen. We would just solve it like we were in the last lesson. We do the same thing to 3 sides. We think about that imaginary line here rather than 2. So I'm dividing by negative 4, remember, so all the signs are going to flip. So I get 1 is greater than x is greater than negative 6. So x is between 1 and negative 6. So on my number line, I have to make my number line, right? This is how this goes. They're both no equals to, so they're parentheses, and that's it. You try the next one, see how it works out. I'm going to tell you that the answer is 3/2 Negative 3 halves is greater than or equal to x is greater than negative 6. And then you should be able to graph that. If you get stuck, come into the chat and let us know. Okay, let me scroll down. Computer and I are having a conversation about that. All right, this is an or. So what we just saw, that compound that we saw a second ago, is an and, where we combine them into one inequality. This is an and. Those are and, you're doing both at the same time. Think about or. Think about the story about the party. I tell you, if you come to the party, I'm either going to have a giraffe or an elephant. So if you come to the party and I have an elephant, great. And you're not stressed about the giraffe. If you come to the party and I have a giraffe, great. You're not stressed about the elephant. But if you come to the party and I have neither, it's a bummer. But if you come to the party and have both, it's like double bonus. I don't have to have both. One or the other will work. Since the inequalities here are connected with or, the solution set of the compound inequality is both parts, both solutions. Okay, so if we solve this, I'm going to solve one at a time. I have 4x is greater than or equal to negative 8. And I have negative 2x is greater than or equal to 6. So the first one I'm going to divide by 4. I get x is greater than or equal to negative 2. Over here, I'm going to divide by negative 2. I get x is greater than or equal to negative 3. Oh, I just have to switch the sign because it was a negative. So my answer is x is greater than or equal to negative 2, or it's less than or equal to negative 3. It can be either. So this is fine, but what you're going to find when you graph it on the number line, it's going to look a little different. So I'll put my numbers on there, negative 2, negative 3. X's are greater than or equal to negative 2, so hard bracket, numbers getting larger. X is less than or equal to negative 3, hard bracket, numbers getting smaller. Okay? One of the things you're going to have to do, the other ones, to put them in interval notation wasn't a big deal. This one's a little different. There is a symbol that we need for or. It looks like a U. So what we would do is we would write the interval notation for each one, from negative infinity to negative 3, and then from negative 2 to infinity. And we're going to connect them with the or symbol. So that's what the interval notation, oh, and that should be a hard, they should both be hard brackets. Okay, that's the interval notation. So let's try some more of these. Okay, so this one works the same. I'm going to add 1, or t. This is going to be x is greater than 3. This one I'm going to divide by 3. X is less than 2. X is greater than 3 or less than 2. So I'm going to put them on my number line. These are just parentheses because there's no equal to. And then I can write the interval notation just like I did a second ago. Negative infinity to 2 or 3 to infinity. That's it. That's all it is. Try the next one. See how it goes. Let's see what it looks like. So push pause and actually try it. Take a minute. I'm going to divide by 3. X less than or equal to 5. I'm going to subtract 5. X less than or equal to 2. So in this case, this is an or. X is less than or equal to 5 or less than or equal to 2. So here's what it looks like. I'm going to put both numbers on there. I know it's a hard bracket, less than or equal to, also here too. And so it's shaded all the way this way, right through that 2. So when I do the interval notation, actually I don't have to pay attention to the 2. I don't need 2 parts because we just shaded right through it. So really it's all the numbers less than or equal to 5 because the less than or equal to 2 is just contained in it. It's part of it. Okay. All right, let's try another. Oh, and it looks like somehow I moved that. Oops. All right, absolute value is a slightly different case. And this one I think This may or may not be new for you, so really pause and pay attention here. Absolute value, remember, is the distance from 0 on the number line. And the thing to remember in that is distances are never negative. You don't say like, I drive south negative 12 miles. You just say I drive south 12 miles. We never drive a negative distance. We don't measure a negative weight. It's just not how it works. Okay, we don't measure distance that way. So think about the values that make each statement true. The absolute value of x, so remember this is absolute value. When the absolute value of x has to come out to be 4, I could put a 4 in here for x, and that would be true. So the absolute value of 4 is equal to 4. But I could also put a negative 4 into there because the distance from 0 is still the same. So in this case, x is going to be 4 or negative 4. Because it's just an equal sign, they're just points on the graph. So I can have a point here and a point here. That's it. For the next one, absolute value of x is greater than 4. We have to think about the numbers that we would get there. So like if I put in a 5, 5 would be greater than 4, right? So if I took the absolute value of 5, I'd still get 5. But if I took the absolute value of negative 5, that would also work. So think about those numbers. They're any number greater than 4 or less than negative 4, like a negative 5, a negative 6. So in the graph here, it's all the numbers to the opposite sides. And I do that with hand signals, like you can see me, but you can't. Oh, and I must have missed the bottom part here. Yep, I did. The last part here, the last case, is when the absolute value of x is less than 4. So think about numbers that would fit in there, like 0 would fit in there, or 1, or even negative 1. The absolute value of negative 1 would still be less than 4. So if we draw that graph, we'd still have the same numbers. We'd have a negative 4 and a 4, and they would be pointed towards the center. The things that make it true are in the middle, in between. Okay, so this just says, and when the absolute value of x is equal to 4, it has the same solution set as x equals 4 or x equals negative 4. The absolute value of x greater than 4 has the same solution set as x is less than negative 4 or greater than 4. And when absolute value of x is less than 4, it has the same solution set as x is greater than negative 4 and less than positive 4. Sounds like crazy talk. I get it. Here's what it means. When we solve absolute value equations, we always need 2 cases. There's always going to be 2 sets of options that we solve for. Always. This is the trick. So when we solve the absolute value of ax plus b equals k, we have to solve ax plus b equals k and, well, really, pardon me, ax plus b equals negative k. We have to solve both cases, okay? So for example, let's look at this bottom one. I have the absolute value of 3x minus 4 equals 11. I'm going to do 2 cases here. The first one is just what I see, 3x minus 4 equals 11. The second one is the opposite case, this negative k. 3x minus 4 stays the same. I only mess with one side. If you mess with both sides, it's going to make a mess. It's going to get the same answer twice. 3x minus 4 equals negative 11. So I'm going to solve both. It's going to work basically the same. I'm going to add 4. I get 3x equals 15. And I get 3x equals, pardon me, negative 7 divided by 3. So I get x equals 5 and x equals negative 7/3. There's 2 answers to this. So those are the numbers I would put in for x. take the absolute value after I solve and get 11. There's going to be two options. When it is an inequality, what happens is when I flip that to that second situation, ax plus b stays the same, k turns negative, and the sign flips direction, okay? So it's ax plus b is greater than k, or ax plus b is less than negative k. Those are the two cases I have to solve. So I would do just like I did a second ago. 3x plus minus 4 is greater than 11, and then 3x minus 4 is less than negative 11. We know on this side we get 5, oops. And we know on this side we get negative 7/3. We did that work already. But in this case, these are my two cases. Two cases, just a little different. Same thing. So this just has the first case written out. So if that's the first case, the second case is less than k. So look at the same, this is the regular case. This is the adjustment that we make. And then let's solve the second one. So two cases, just like we did before. 2x plus 1 less than 9. 2x plus 1 greater than negative 9. So minus 1. I get 2x less than 8. I get 2x greater than negative 10. Divide everything by 2. I get x is less than 4, or x is greater than negative 5. And then you're going to interval notation and draw and do all the whole things. Okay, two last ideas here. First, the absolute value of an expression can never be 0. Or sorry, it can be 0. That was silly. It can never be negative. Okay, we can't take an absolute value and get a negative answer. It's not possible. So what I can never have is a bunch of stuff in here that it's not possible to get a negative answer. Okay, the absolute value of an expression only equals 0 when the expression is equal to 0. Whenever you're solving an absolute value equation, you always isolate the absolute value before you solve. So what that means essentially is this. Let me show you real quick an example. I'm going to insert a new slide here real quick. So if I have something like the absolute value of x plus 6 minus 7 greater than 2. Plus 7. Nope, minus 7 was right. Okay, I cannot do two cases of this first. The first thing I have to do before I make my two cases is add that 7 to the other side. Before I do my two cases, I have to have my absolute value alone on the left or right and my number alone on the other side. I can't have extra numbers floating around. So before I do my two cases here, I'm going to add 7 to both sides. Okay, then I can split it, but I cannot split it sooner. Okay, it has to be at this point. Then you can keep solving. But keep in mind, you're going to see this in Alex, so just pay attention to it. All right, here are some for you to try. I am going to go through and write in the answers. We have seen enough examples that you guys can figure this out, so go through and try them on your own. If you get stuck, you can bring it to the chat, to the discussion. Let's see, for number 1, a should equal 5 or negative 5. For 2, x should be greater than 0, or x is going to be less than negative 4. For number 3, x is going to be less than or equal to 7, and it's going to be greater than or equal to negative 43 over 5. Yes, you can just leave that like that. Don't die. For number 4, x is going to be greater than negative 4, or it's going to be less than 5/3. Okay. And then for the last one, X is going to be less than or equal to 15, or X is going to be greater than or equal to -5. Come ask if you're stuck, but these are good for you to practice on your own. That's a part of doing math. We all have to just try it sometimes. You can do this. All right, let me know how things go. I'll see you in the next section.